gas laws. With Boyle's law, at a constant temperature, pressure is inverse to volume, in such that with the temperature remaining the same, by increasing the pressure by pushing down, like in this example, you push down, increasing the pressure put onto the molecules, it decreases the volume because there's no more, because it decreases the space between the molecules, which creates greater pressure. Charles' law is at a constant pressure, volume is proportional to volume. This is a good example, which is basically the balloon in normal temperature is fully blown, but when you go outside in the snow, it deflates faster because the coldness is basically slowing down the movement of the molecules, causing them to huddle together more. Gay-Lussac's law is at a constant volume, pressure is proportional to temperature. And this is a good example, which is the pressure, tire, aerosol can, and heater, they'll all explode if given a high enough temperature, which also includes a propane tank, but yeah. And then the combined law is basically the product of pressure and volume is proportional to temperature, which basically constant pressure volume is proportional to temperature. Okay. So how this is going to be explained is the product of pressure and volume is proportional to temperature. Basically, the relationship changes based on like the relationship between pressure and volume is proportional to temperature. It's sense where if you take volume out, pressure is proportional to temperature. If you take pressure out, volume is proportional. Yeah, if you take pressure out, volume is proportional to temperature. Also, if you take temperature, then pressure and volume are inversely proportional, which brings to Boyle's law. So it brings all three of them together. And that's about it.